Welcome, everyone. Good morning. My name is Pablo. I work in the Foundry IQ team. And we're very excited about the announcement of Foundry IQ here at Ignite. So in this session, what I wanted to do is dig into the details of what Foundry IQ is, what it looks like to use it, how, as a developer, the developer experience comes across, and give you a little bit of detail of the internal mechanics of Foundry IQ. So by way of context, it's interesting to see, maybe some of you can relate to this. When I use Copilot or any other AI day to day, the way the use has evolved over the last three or so years can be interesting. One of the things I noticed is in the past, I crafted these very carefully written questions. Good grammar, no spelling, short questions. I really wanted the thing to succeed. If you look at your logs of the questions recently, when I look at mine, they're this just stream of thought, like no care for everything. Who cares about grammar or spelling or anything else? Or even half questions and you expect a good answer, right? So that evolution has to do with how effective these things are evolving to be, where we can avoid having to spend a bunch of energy on just over-specifying, and we can still get good results. Now, when you look at the systems you build in your companies for your customers, the expectations has grown the same way. And our goal with Foundry IQ is that when it comes to connecting these AI-based applications to your enterprise data, these systems are just as effective, no matter how complicated or convoluted these questions are. Let me give you an example. So let's say the setting is we have on-site technicians in a factory plant, and they are, they troubleshoot equipment and whatnot. Kind of the old version of this question would be something like this, where, perfectly crafted question. Whoa. This is not projecting. Okay. No, that's not it.
Is that it?
No. It's that.
This, right? Advanced. What do you want to be?
Oh, DAO is there. Perfect. Thank you. A kind of a nicely crafted version of the question is something like this, where short question, well crafted, some specifics of the domain this person is working on, and technically this question is also a piece of cake because things like CTL11, whatever that means, has high discrimination power. You'll find the one document that does this, feed it to the language model, boom, you get a good answer. That's not what we're getting these days. We get things like this, where the person is just thinking through the problem. They're like, I don't know, this is the label in the machine that I have in front of me. This light is red. Maybe it's a problem with the power. The code has this other label. I don't even know what that is. What do I do? Do I replace it? So that's the kind of questions that we want to be effective at answering. So this breaks a lot of assumptions. At a minimum, the data to answer this question is probably all over the place. Like, for example, in this case, let's say this company gets equipment from many vendors. We take all the equipment manuals and specs. We dump them in one lake. So all the information is there, say, as markdown files. So I want to get information from that for things like this. On the other hand, we have company policy that is maintained by the company in M365, where people edit documents and maintain the rules for how to proceed in different circumstances. And there is some data that may not even be in the company's own data repositories, but it may be public. Like, for example, this is some electrical standard that to answer this question, you may want to go find in the web. So if you want to do this yourself, you have to deal with a lot of moving parts. Some of this is external grounding. Some of this needs to be indexed. It's in multiple places. You have to choose where the data comes from. So our goal with Foundry IQ is to tackle that entire problem space, to make it so that you can connect agents to your entire scope of knowledge and don't have to deal with the details of how you connect to individual components at individual times whenever it's the right time to pull them in. So why don't we take the question we're just looking at and give it to Foundry IQ and see how it does. So here I'm in the new experience in Foundry. I'm going to go to build. And I have an agent pre-created called the technician agent. I have some instructions and whatnot. And let me go ahead and paste the question here. Same question we had in the slides. And I'll let this run. This will take a second. So notice that I have no tools, nothing in this agent. The only thing I have is a factory KB, so a knowledge base of all things around my factory plant. The things that are there include the stuff I have from the machine specs and manuals and whatnot. Those I have in one lake. You can see here, these are a bunch of markdown files. Also, data is maintained in SharePoint when it comes to things that my own company edits every day. So in this case are all the company policies and so on when it comes to repair. So, and then there are, as I mentioned before, some of these things that are on the web. So if I come back here, well, this is taking a second, so let's give it a second. Oh, there. So if I look at the answer, you can see that some of these things obviously are coming from the product specs because it has a bunch of details about these. Some of it may come, like this replace policy may come from the product manual. And the statement about UL 817, it's some public web standard. So it just went to the internet, found this information, and told us what it is about. So in just 1 second, this agent connected to all these data sources, grabbed all the facts, fed them to the language model behind this agent, and produced an answer for us. So what's going on? How do we think about constructing a thing like this? Central to Foundry IQ is this idea of a knowledge base. I just mentioned the factory knowledge base, which we were using in that agent. So the idea of a knowledge base is we wanted to create a kind of a representation of each of the knowledge domains that your agents may need to work on. Sometimes you'll have things like everything related to maybe human resources, or everything related to sales, or in this case, to on-site technicians kind of related information. So for each domain, it's unlikely to expect that all the information will be in this one place and in this single format. Most likely, in any given domain, you have multiple pieces of data that are maintained by different people, and they all converge together. Now, if you want to do this inside the agent, what do? Well, you have all the agent-specific instructions and tools and whatnot, and then you have to also explain where all this data is, how to access each one of them, how to select when to use which one, and whatnot. So that creates a big agent. But we have practices for this in software engineering. When things get complicated like this, what you do is you separate concerns. So we want to create a setup where you can create agents that are very focused on the task at hand, and separately create knowledge bases that know everything about each knowledge domain. Then when you want an agent to work on a particular knowledge base, you just refer to it. This way, we can hide the complexity in the right places, and we make it more productive to create more agents. Because once you have a crafted knowledge base for any one domain, all the agents that need to work on that domain can just point at that. Now, knowledge bases need access to information, and the metaphor we use for that is knowledge sources. Think of knowledge sources as an encapsulation of, first, all the mechanics of how to access a source. So, connection information, authentication, how we propagate your user identity, even instructions on when to use which one of them, and so on. Now, on top of that, the knowledge base uses the agentic retrieval stack to actually kind of choose when to use what and assess whether it got the right information or not. And we'll talk a little bit more about that in a minute. But now I want to focus on the kind of the source layer. One of the significant shifts that we are going through in the context of Foundry IQ is that we are not just indexing everything, and if you can't index it, you can't use it. The reality is that in many cases, you want to actively index data. Sometimes you have to. For example, if you have, say, a set of PDFs in blob storage or in OneLake or things like that, you can't, at question time, go through 1 million PDFs and try to figure out what matches the question. So you want to create indexes for that. And Foundry IQ will do it transparently for you and will maintain them up to date. It'll do all the things you have to do under the covers, like chunking, vectorization, all those things. And it'll maintain indexes fresh. Now, in other cases, say, for example, for web grounding, we don't want to copy the web. And sometimes for extensibility purpose, for example, you want to access an application that is live. So what you want is us to access real-time information from there. In that case, we have support for remote sources, where at query time, we federate the query out, bring the results, and then combine them. Even sometimes you want a little bit of both, depending on the context. For example, SharePoint, which is one of the most popular data sources for this stack, we actually offer both options. You can point us a specific site and say, just create an index on that, because I want to tightly control how I process the data, the latency, everything. Or you can say, hey, that's my M365 tenant. Just call the tenant directly. Don't index the data. And you can choose either one, depending on the scenario. The other interesting thing about fitting data sources in this layer of the stack is that both remote and index sources participate in the rest of the retrieval system. So for example, our re-ranking stack runs on all the retrieval sources. The result of this is you actually get a boost in quality no matter where the data comes from, because we re-rank results as we pull them. So so we talked about knowledge bases and knowledge sources. Let's look at what it looks like to build one of these agents backed by a Foundry knowledge base from scratch. So what I'll do is I'll start by going to the knowledge part of Foundry. Here is the Factory KB knowledge base that we talked a minute ago about. So what I'll do is I'll create a new source, and I can pick from a number of places where I could have this information. What I'll do is, just to change it up, I'll use blob storage. I have a container in blob storage that has the same information I had in OneLake a second ago. So I'm going to say blobs. We're going to call this the specs. This has the same machine specs data. So we'll say in instructions, use for machine specs and manuals. I have to pick storage account. Everything is Zaba in this conference, so we'll go with that. I'll point at the machine specs container. And the last thing I'll do is I'll pick an embedding model, click create. Actually, click on that. And then click create. So what this will do is it'll look at the source, sample the documents, get a sense of what to do, then ingest all the documents into a knowledge source and get me a knowledge source fully set up. Once it's set up, it also will maintain the source up to date as content changes in the blob storage account. So we can see here, now I have a source, and it's indexing the content that was already there. I can also add existing knowledge bases that I might have, knowledge sources that I might have created for something else. Like, for example, here's the OneLake knowledge source I used a minute ago, and here's the SharePoint policies one. So let's add the SharePoint one. So now I have these two. Also, the blob storage one finished, so I have two of them ready to go. What I'll do is I'm going to call this the demo KB. I'll say demo knowledge base. And the last thing I'll do is I'm going to select a language model that we will use internally in the knowledge base when we need to do planning, answer synthesis, and things like that. So with this, I have everything I need to have in order to create a knowledge base. So now we're set. We have this object, this knowledge base, that any agent can use to ground information. So what we'll do is we'll go to agents. And let's also create a new agent from scratch so we see the entire workflow. I'm going to call this the demo agent. And in the agent, so what I'm going to need some instructions. So I'm going to paste some from here. And I'm going to go to knowledge, say add knowledge, connect to Foundry IQ. And then here is the demo knowledge base I created a second ago. So I'm going to hit connect. So once I connected my agent with my knowledge base, now this agent knows everything that that knowledge base knows. So if I want to try it, hit save on this. Now I can come here and ask let's ask a question about this same machine that we were dealing with a second ago. So this will consult. In this case, we have these two knowledge sources. And by default, we ask for this. You can disable this in the API. And soon we'll make this a default. For non-side effecting operations, we'll make it a default not to ask. So anyway, so you can see like the agent found information that we were looking for and produced an answer for it. So in just a minute, we created a knowledge base from scratch. then connected it to an agent, and then have the agent answering questions on top of that knowledge that we had put together. So I hope you can get a sense of one of our goals with this is to make it so that getting started with this system is straightforward and gets you very quickly into experimentation mode. Now you have a working agent, and the next thing to do is to actually dig into, is it doing the work I needed to do, run evaluations, and get it ready for deployment. Now, the work we've done in Foundry IQ, I just showed you the entire experience in Foundry. Now, this is built on Azure AI Search technology. So Azure AI Search is our retrieval system as part of the Azure platform, and it's the place where we've done a lot of work to stay on state-of-the-art quality for retrieval, everything that has to do for everything from relevance all the way to extreme scale with great economics. So knowledge bases you can create and use directly in Foundry and never leave Foundry. But you can also use directly in Azure Search. So Azure AI Search has a new collection. There is the knowledge bases collection. You can see them in the portal. You can use them through the API. And generally speaking, if you're an Azure AI Search user, you can use your existing footprint right away to add knowledge bases and even connect your existing indexes in addition to anything new you might create. So this gives you an option for how you consume this, depending on what you're using today and what is your preferred starting point. Let me actually give you a quick example of this in action. So I'm going to take the same knowledge base we created a second ago. Let's make a couple of changes. By the way, this is a great aspect of separation of concerns. You can evolve the knowledge bases independent from the agents. So when you update a knowledge base, you don't have to go through each agent and then update it. In this case, I'm going to change a couple of settings. I'll go through what this means in a minute. There. And when I change the output mode, by the way, I can ask the system to give me raw grounding information or to answer synthesis. And when I do synthesis, what I can do is I can give instructions. Like, for example, I'll say, answer in fewer than 80 words. So now that we have this set up, what I'll do is I'm going to go to VS Code. And let me show you real quick what it looks like to use this not from Foundry, but from Azure Search, even though I created this directly in Foundry. So first thing I need to do is set up a kind of a client. Just like if you use Azure Search, there is a search client class, depending on the SDK, depending for the language you use. You can see here I have a new class called the knowledge base retrieval client, which does all things knowledge bases. And I'm pointing it at the search instance that is underneath that Foundry project. So when I run a retrieval step here, I don't call the search method. Think of the search method as the thing that gives you full control. If you want it, search method will do it for you. Now, sometimes what you want is to stay high level and say, this is the input I have from the user, just run the retrieval process. So this retrieve method does that for you. And in this case, I gave it the same question as before, and I have a little loop to print the output. And you can see here that I get the answer, and even I get all the references from the different places that the system consulted in order to answer this question. Not only I can use this from the API, but also this is fully usable in the portal. So if I go again to the same Azure Search service instance that I was using a second ago, you can see now that we have kind of an agentic retrieval section, and I can see all my knowledge bases, including the one we created a second ago. We can see the sources. And one thing that we worked hard to make sure it stayed the same is if you have a scenario that fits really well on our defaults, this thing needs to be a piece of cake. On the other hand, there will be cases where you want full control. What types of indexes, what type of, vector quantization you want to do, what processing you want to do over ingestion and whatnot. If you want the control, you have it. You can actually access all the underlying pieces. You can see here all the indexes we created, all the indexers that are backing those indexes, and so on. So this gives you full control when you want it, but it gives you very high productivity when you're creating the majority of your scenarios that typically fit the defaults. The other thing we wanted to do is ensure that no matter where your data is, we give you a path to access it. So we'll continue to add native connectors for things that we need at the bottom of the stack and then enhance them and it kind of connect all the dots within the stack. But the reality is that you may have your own application, you may have some third-party vendor that we haven't kind of worked with, and so on. So what we did is we chose to use MCP servers as a way of connectivity. MCP may not be the perfect protocol for the task, but the great thing about MCP is that right now it's everywhere. So if you have a third-party application that you want to integrate with, very likely has an MCP server. Also, the frameworks to create MCP servers are getting really good, which means if you have your own internal application, it's actually pretty easy to create an MCP server endpoint around this, and now it can participate of the retrieval system. When we use MCP, of course, we only use non-side effecting tools because this is a retrieval stack. We don't want to go make changes. Once we get the results, we use a set of heuristics to turn the output of the MCP server into items because we want to operate on bits of information that then we can rank and select the best candidates for the task. And as I mentioned before, we still re-rank them. So if you put an MCP server in this layer, you may actually get a quality boost on top of it when our re-ranker does its job. MCP support in particular is in private preview, but if you are curious, you can sign up there today to start using it. I'll give you a quick example. So far in this knowledge base, we have data that comes from blob storage and data that comes from SharePoint. Now, let's say that like in many of these machines today, there is a bunch of software in addition to hardware that the company maintains to operate these machines. So software issues are in GitHub. That's where everybody has them. So I have my GitHub repository here, and I have a bunch of issues related to the software side of that machines there. So what if I want to do grounding on all the documentation I have and GitHub? Well, GitHub has an MCP server, so let's hook it up. So I'm going to call this the issues knowledge source. I'll say use it for software issues. So I'm going to paste the URL to the GitHub MCP server. And the MCP server from GitHub does a lot of things, but one of the things it does is it has a tool called the search issues tool. So that's it. I'm set, actually. So now I can use this knowledge base, and when I use it, GitHub is one of the options. Now, sometimes you want to steer how the knowledge base uses different tools. In this case, GitHub issue search has a little bit of specifics that I want to kind of craft carefully. So what I'll do is here, I'll give it steering instructions that says when using the software issues for search, only query one word at a time, and so on. So effectively, I'm telling the system a little bit what is the right way to use this particular source. So now that I have this here, let me show you this in action. And while we're at it, let me keep peeling the layers so you can see what's going on under the covers. Of course, you wouldn't do this directly calling the HTTP API. But I wanted to show you that to call these systems, in the end, you're calling the search API. There is a knowledge bases collection, and then there is like this, in this case, 𝗦𝗲𝗶𝗶, which is created. A simple question looks like this. In this case, we want a question that includes GitHub. And I want to talk to GitHub with my GitHub account. So it sees what I can see. So to do that, what I have is I have my GitHub access token. And when I run this search, great. Oh, I didn't call it issues, did I? OK, that's better. Typo somewhere. So when I call this kind of retrieve method, I get kind of the answer from the system. But also you can see we called the MCP. This is I just enabled the trace, so you can see what's going on. You can see we called the MCP server for GitHub. We searched for this particular keyword. And you can see all the grounding information that in this case we got from GitHub. But the system chose to do that, to query that particular source in this case. So just with that change, now we have a knowledge base that grounds on SharePoint, blob storage, and GitHub issues, all without the agent really not needing to know any of these. All right, so I mentioned agentic retrieval a few times. I thought I would take a minute and actually break down what do we mean by that and how does it work under the covers. So when you issue a request to the retrieve endpoint, you give us either a set of intents or a bit of conversation history, and you can also give us steering instructions, as I showed you a minute ago. First thing we do is we do query planning. We look at what you gave us, and we plan what is the right approach to run this query. We may do things like query decomposition and things like that. And we also do source selection, meaning we choose which of the knowledge sources that are configured we will actually use in this particular case. So then we take the sources we selected and all the queries that we produced, and we run all the queries against all the sources so that we can start collecting all this information. When we get the results, we re-rank them using our L2 ranker so that we get the best candidates from each one of the steps. Then we need to decide if we got the very best, and if so, can we be done with this and return it to the caller, or if we need to keep looking. So for that, what we do is we have a custom-tuned SLM that does two things. First, it gives us even better re-ranking on kind of fewer, more pointed documents that we picked from the previous ranking layer. And we also use it as a fast exit check. So if the SLM has high confidence that we have all the data we need, we'll exit. Now, if it's not sure, what it'll do is we'll loop back and go through a reflection stage where we call the full LLM that we have configured to take a second look, make sure. If that step says that we should leave, then we exit. If not, we replan, except this time we know what we got before, and we correct for whatever it is that we were missing there. We run through the process again, and eventually we'll exit. We'll combine all the best results from this. If you enable answer synthesis, we'll also synthesize answers, and also we'll give you grounding results and a trace of activity. So let me show you real quick what a trace of this activity looks like. So what I did before, go here, is I did a run for the same query we have here, make this a little bigger, same query we've been using, this long question. And I run it by this little tool. This is not part of the product. It's some quick hack. But what it does is it just dumps the activity history in a way that is easy to see. So you can see that in this case, we did 2 iterations. We did 11 different retrievals, and generally a bunch of activities to kind of give you the best grounding information for this query. You can see in the first iteration, the query planner ran, and it decided to do 3 sources and formulated 3 different queries. And you can really see that it really understood what's going on. Like one of the queries is about the standard, this UL 817. The other one is about the actual equipment and what does that equipment do. And then the other one is about the policy aspects. So good job at kind of decomposing the query. It ran all of these. And then at the end, it looked at it, and it wasn't convinced that it had enough information. So it went into a second iteration. The second iteration actually selected fewer sources, because clearly the thing that the system is not convinced about is the policy to actually replace or repair the equipment. So it asks a separate question about whether, to chase more information about this policy. And once it was convinced, it gives us kind of an assessment of how many tokens we burned in this process and whatnot, and it gives us an answer, where the answer synthesis here gives us effectively an answer grounded on all of this information. And you can see here that it touched documents, in this case, from SharePoint, some PDFs from there. It pulled data from blob storage for the machine specs. And there are some references probably down here to the web, where it pulled information about this public standard. So all of this happens under the covers. Typically, you don't look at the trace like this. But we also wanted to make it transparent. So if you're debugging one of these, you have access to where all the steps that we did in order to get you the right answer. I included a table here just for just so you have it for reference. So because one of the interesting things is you can dial how hard you want us to try. And our goal with this was to say, there's so many parameters that control the agentic retrieval system. So instead of giving you an enormous parameter space, we boiled it down to the effective trade-off of latency versus quality. Because in the end, that's the thing that you typically care about. Is sometimes you want to make sure you get a fast answer. Sometimes you want us to take our time if we need to get you a better answer. So we have these 3 modes: minimal, low, and medium. And each of them has different characteristics because they're focused on different things. If you go in minimal, that's pretty much the same as searching. So we'll give you a sub-second answer, super fast, not as sophisticated. If you can take the time, then you can go to low and medium, and you'll get better answers. Sometimes you don't know, and that's a nice thing about these systems is that they can adapt to the circumstances. So we talked about some of these data sources being remote, so we access what we get, so to speak. But some we actually get to index, and when we index them, we can do a lot of work on data preparation to make sure that we have the best data organization, data representation to get the job done. Again, we build on the existing search, Azure Search ingestion pipeline, but we really up-leveled the experience. As you saw before, it took me just 2 clicks to set up, say, a blob, an index from blob storage or a similar store. That said, if the easy mode doesn't work for you, you can still go inside and decompose it into all of its parts and control each part individually. Maybe you have a custom step in the middle. Maybe you want to control how we do chunking or how we vectorize content or things like that. Second, here at Ignite, we're announcing that Azure Content Understanding is hitting general availability, so it's ready for prime time. This is deeply integrated into Foundry IQ. So when you create one of these indexing knowledge sources, you can choose to do minimal processing, which is fast, but it's very simple, so it can only do so much. Or you can just switch to standard, which uses content understanding. I'll give you exceptional quality for OCR, PDF parsing, things like layout understanding, table handling, and so on, without really having to do anything. The only choice is between these two. One is a little slower, and it costs more. The other one is faster, but it does fewer things. So you have control over that. And then finally, we also do a bunch of work around multimedia support, not only because you may have, say, pictures in a repository somewhere, but because a lot of business documents are multimedia documents. It's very common for a document to have charts or schematics or things like that, and we want to do a good job on that part as well. So much so that when you index this data, you can tell us to do things like, sometimes you want us to, say, vectorize pictures, but sometimes you want us to do descriptions of pictures. And we call this verbalization, and we use it when you have to search lots of pictures that look almost the same. Think about your business charts. On first look, all charts look the same. But what matters is the individual numbers, the parameters, and whatnot. Same with the schematics. Like a bunch of boxes with arrows, they all look similar, except that the labels in the boxes and where the arrows point at really matters. So you can do some of this by embedding images, but we found that complementing this with image verbalization helps a lot, and we do that out of the box. So I'm not going to run through the whole process, but let me show you where you control some of these things. So first, content extraction mode is the place where you control whether you want us to do a fast job, or you can switch to standard, which will use content understanding under the covers, and you will get better quality output. The other thing you can do is you can give us a completion model here. It needs to be one that supports images. And if you give us a completion model there, we'll use it during indexing for verbalization. And the result of this is that now we have text descriptions of the images that we can search on, and that complements other techniques really well and makes it very effective for retrieval. Now, another observation from how quickly agents are growing in every enterprise is anything that is high stakes needs to be well understood and well set up in terms of access control and security in general. So as agents become more popular, agents need to be subject to the same bar. And we've done a lot of work to make sure that you have the building blocks needed to ensure that that works across the stack in Foundry, including in Foundry IQ. Two things we've done a good amount of work on are access control and governance. So for access control, what it means is you can choose to access every index or every knowledge base, in the case of using the knowledge base from the top, using the calling user's identity or agent's identity. And when you do, if the underlying components are set up for access control, then it's as if that knowledge base only had the content that that user can see. So any question is grounded only on the subset of information that the user can see, And if user access changes, then these things change as well. You can do this on your own custom indexes, and we will do it for you automatically for things that have access control information on the source. For example, if your data is in Azure Data Lake Storage, which supports access control, or if it is in SharePoint, which of course has document-level access control, during indexing, we'll propagate that into the index so that the index has the same information. On the other hand, we also done a lot of work on governance, where if your organization uses Microsoft Purview and uses document sensitivity labels, we want those labels to work, and we want to honor the semantics of the labels. So for starters, if a document has a label, it's encrypted. So a regular indexing system can't index it because you can't decrypt the document. You need to integrate with Purview for that. And once you were able to index it, you still need to be able to propagate the label information. And if the sensitivity label has information that makes it so that a subset of the users can see it, then you want only that subset of users to actually have access to the document, which means for everyone else, it needs to be as if it doesn't exist. So we do all of that out of the box if you configure our support for Purview labels, which means you get indexing. You'll also get propagation of the information and enforcement of access. And we'll even, in the API, we'll return the labels. So that means that if you're crafting a UI, like the example on the screen, you can, in the response from, say, an agent chat window or something like that, you can show the labels just like you would see, for example, in the native Office products. So this is a way for you to enforce and be clear, kind of be transparent about the rules for sensitivity labels within your own applications, just the same way we do it for things like Office. We built a full example of this in case you want to try it. Like there's a link there. So that's you can replace it with your data and deploy it in your organization and try it out if you're curious what this would look like. All right, so we talked a lot about mechanisms, like how we create this knowledge-based abstraction, how we do agentic retrieval, and so on. So obviously, the question is, does it actually work? Is it any better than doing just a straight search against some one index? So this is an area where we spend a ton of energy. Our science team not only works on kind of creating data sets and validating the work, but they work on making sure that we adapt our approaches so that we get the best out of the data that we have in whatever is the setup that you happen to have, because often you don't control how the data is partitioned and things like that. So we have a lot of data on this, and we published a full write-up. I'll share a link at the end. But I thought I would share with you 3 examples. So first question is, is it actually better? So is agentic retrieval better? And the comparison here is we said, on one hand, we'll do agentic retrieval. On the other hand, we'll just brute force, just search all the knowledge sources and hope for the best. So in that case, we see a 36% boost in answer score when you enable agentic retrieval. And we do this on the hard questions. The easy questions are easy. So all the data sets that you see here are all custom crafted to be difficult. And you see a span between 16 and 60% improvement in answer score just by turning agentic retrieval on. Second question we wanted to answer is, if the thesis is that data is often split up across a bunch of different knowledge sources, are we really effective at bringing it back together? And you can think of two cases of this. One is it's fragmented between your own data sources in your org. In the other case is it's fragmented between your own data and the web. So the way we tested this is we took a data set. This is a finance bench. It's like some public data set. And so finance bench has finance-related information across multiple finance sectors, like energy, consumer, and so on. So what we did is, instead of building one index, we built 9, 1 per category. And then we ran our answer score evaluations to see how we did. And you can see we do in the 90s, like about 90 for answer score. We'll do like 89 for low and 90 for medium, showing that even when the data is highly fragmented, we can find all the pieces and put them back together. Second experiment, we just caused damage to the indexes. We took 3 out of the 9 out of the way, and we ran the test again. And you can see how the answer scores go down into 53, 50, showing that we were really using the other data, and now it's gone. And in this particular case, this finance information is public. So the next question was, can we, if we plug in some connecting information, can we connect the missing dots? So what we did is we enabled web grounding. And because this information is public, we can connect the dots between the other data sets and the missing data sets using web grounding. And you can see a significant recovery of answer score, like 24 points for low and 34 points for medium. This also shows that there is a real trade-off between latency and quality, where if you really want the quality, and you're able to pay for it with latency, as in your users will wait, then you can get a better response. And the medium setting is set up so that we try to exit early. So that doesn't mean that all the time will be slower. We'll be slower when we need to. So related to this, final question is, do we do a good job at that? So I mentioned before that we have a fast exit check, and then we have a detailed exit check. And the question is, do these things save time at the right times, and do they do the extra work at the right time? So the way we evaluated this is we first run the evaluation in minimum setting. So minimum setting does no planning. It just queries all the sources and retrieves the content. And then we evaluate answer score on that. And that's a benchmark of, if the query was easy, we should get good answer score at minimum. If it was hard, we should have tried harder. So what you see in the table is, first row, piece of cake cases. So answer score is really high, and both the fast check and the full check agreed that they had high confidence that we should exit, meaning we should not do loops, no iteration. So that saved us a bunch of latency, a bunch of tokens. That's great. Second case, answer score is high for minimal, but the questions themselves are less obvious that you should exit. So you can see fast check bails, says, I'm not sure, let's go to the full check. The full check actually has a very different score in this case, because it's able to understand what's going on better, and you see a high percentage of exits, suggesting that it understands what's going on, and it's consistent with the minimal scores being pretty high. So we didn't need a second iteration. And then the last row, the fast check goes like, this looks really hard. Like I don't think we have enough information. We should loop. The full check says the same thing, and that's consistent, because when we don't loop, when we are in minimum and there's no iteration, we get lower answer scores. So indeed, more work is warranted. So this helps us effectively kind of adapt dynamically, depending on the nature of the question, to how much work we should do to get you the best answer without always incurring the entire cost, both in latency and kind of in token count. We made a lot of more evaluations along the lines of these ones, and we published them. So you can see exactly what numbers are we looking for, what is our methodology for evaluating this, and what are the results. And this hopefully will help you assess how this best fits on your particular application or scenario. So we published a description in detail of what Foundry IQ is. That's what the first link is there. Second link, the aka.ms/kb-evals, contains, again, like methods and lots of results for how we look at measuring the quality of the system and making sure that Foundry IQ really makes life easier for you, and it makes the experience of the applications you build much better for your end users, because they'll get their results more often and of better quality. So I hope you have a chance to test Foundry IQ soon. If you do, please let us know what you think. This is for us an exciting moment. We've been working on this for a while, and we really believe this will help everyone be more productive creating agents and producing agents of better quality with better experiences for end users. If folks have questions, I'll be outside the door if anybody wants to chat after this. And with that, thank you so much for attending.